This lecture will cover the importance of sedimentary rocks and their origins, which is necessary to understand the depositional environments throughout Earth history. We will also start the discussion of sedimentary rock types with detrital sedimentary rocks. Sedimentary rocks cover approximately 75% of Earth, and they comprise about 5% by volume of Earth's outer 10 miles. They are important for understanding Earth history because they contain evidence of past environments and life forms and are an important resource for coal, oil, and other fossil fuels, as well as an important resource for groundwater. Sedimentary rocks originate as products of mechanical and chemical weathering. Sediments and soluble constituents are typically transported downslope by gravity, where the sediments are then deposited and subsequently buried. As deposition continues, the sediments are lithified into sedimentary rocks. There are two main types of sedimentary rocks, detrital and chemical, which includes the organic sedimentary rocks. Sedimentary rocks are first classified according to the type of material they are composed of. There are two major groups: detrital rocks, which have a clastic texture composed of discrete fragments cemented together, and chemical rocks, which have a non-clastic or crystalline texture where the minerals form patterns of interlocked crystals. In this chart, you can see that the detrital rocks on the left are classified by particle size, and on the right, the chemical sedimentary rocks are classified by their composition. Detrital sedimentary rocks form from sediments that have been weathered and transported. The chief constituents of detrital rocks are clay minerals, quartz, feldspars, and micas. Particle size is used to distinguish among the various detrital rock types. Particle size categories range from microscopic grains all the way up to boulders. The common names for the sediment that make up these sedimentary rocks are mud, sand, and gravel. Mudstones and siltstones are made up of particles of equal to or smaller than 1/16 millimeter in diameter. Sandstone is a general term for any sedimentary rock made up of sand-sized grains ranging from 1/16 to 2 millimeters in diameter. Anything larger than 2 millimeters in diameter is a conglomerate or breccia made up of gravels. Shales are made up of silt and clay-sized particles. Shales form from the gradual settling of sediments in quiet, non-turbulent environments where the sediments form thin layers that are called laminae. Shale has fissility, meaning that the rock can be split into thin layers. It crumbles easily and tends to form gentle slopes in a landscape. Shale is the most abundant detrital sedimentary rock. This is a photo of a shale. Because the particles are so fine, they are excellent for preserving the fine details of fossils and often split easily to reveal fossils between the layers. They are also an excellent source for microfossils. Sandstones are composed of sand-sized particles and can form in a variety of environments. They are the second most abundant sedimentary rock. While quartz is the most abundant mineral found in sandstones, any rock composed of sand-sized particles receives the designation as a sandstone. Some examples are quartz sandstone, predominantly composed of quartz, Arcos sandstone, which contains appreciable quantities of feldspar, and greywacke, which contains rock fragments in addition to quartz. This is a piece of quartz sandstone. You can see the individual grains in the close-up photo. Sandstones often preserve sedimentary structures, like the crossbeds in this sample. The reddish color is caused by iron oxide cement that is filling in the spaces between the grains. The characteristics of the grains themselves will often give us important clues about the environment that the sediment was deposited in. The particles in sandstone vary and are classified by their sorting and shape. Sorting is the degree of similarity in particle size in a sedimentary rock. If all the grains in a rock are of similar size, the rock is well sorted. But if the grains in a rock are different sizes, both large and small, the rock is poorly sorted. Sorting can help decipher the depositional environment of the rock. Well-sorted rocks had a constant energy that removed rocks or particles of all but the largest available sediment size that were left behind. Poorly sorted rocks typically had a low energy depositional environment. Particle shape in sandstones varies from rounded to angular. The degree of rounding is indicative of how far the sediments have been transported or how long they've been in the environment. Rounded sediments are typically transported great distance, while angular sediments are only transported a short distance. In the top diagram, you can see examples of very poorly sorted rocks to well-sorted rocks. Sediments are poorly sorted when they have multiple grain sizes, whereas well-sorted rocks have particles that are all nearly the same size. The bottom diagram shows the angularity or roundness and the sphericity. Do not confuse roundness with sphericity. Roundness refers to the smoothness of the outer surface, whereas sphericity refers to the equality of the x, y, and z axes in a three-dimensional particle. Detrital sedimentary rocks composed of gravels are called conglomerate or breccia. Conglomerate consists of rounded, gravel-sized sediments, and breccia consists of angular, gravel-sized sediments. Both types of rocks are poorly sorted. The photo on the left is a conglomerate with rounded gravel-sized particles. On the right is a breccia with angular gravels. The gravels in the conglomerate have traveled a great distance or have been traveling for a great deal of time, or both. The particles in the breccia have not traveled far and likely have not traveled for a great deal of time. This is the end of Sedimentary Rocks, Part 1. In Part 2, we will examine the processes that form chemical sedimentary rocks and how they are further classified.